Hi, I'm Chris, and in this video we're going to take a look at what a derivative actually is. So some of you who are beginning the year with calculus are probably first starting to hear a little bit about derivatives, maybe get introduced to a formula. You might have even covered power rule already. And we'll do some examples of that in solving these problems, but for right now I just want to talk a moment about what that actually means when we talk about a derivative. So the derivative of a function is the slope of the tangent line to that function. That's what a derivative is. So important to keep in mind is that when we look at a function, no matter what point on our function we're looking at, if we were to solve for the derivative at that point, we would end up with the value of the slope of the tangent line. And I'll show two examples on this first function and two examples on this second one, just so we have an idea of what we're talking about. So here, for example, if we apply power rule, which says that to find the first derivative, you multiply the exponent times the coefficient, so that would be 2 times 1, which is 2. You leave the variable there, and then you subtract 1 from the exponent. So 2 minus 1 gives us an exponent of 1. So the derivative of this function would be 2x. And to show you how that works, if we pick a couple points, let's say we plugged in 0 for x. So the derivative at 0, when we do 2 times 0, anything times 0 is 0. So hopefully if we're calculus students, we know that already. So that would give us a 0 as our value. And if we look at the slope of our tangent line at that point, x equals 0, we're talking about right here at the origin. And if we look, that would be like a horizontal line, because right at that exact point, we see that just at the bottom of that curve, it's completely flat, it's a horizontal line, and hopefully, as we've experienced in other math classes, horizontal lines have a slope of 0. So that's where we get that value. Now let's take a look at a different point. Let's say I were to plug in, for example, -2. Well, if we plug that into our derivative function, 2 times a -2 in place of x, will give us a -4. And what that means is that when x equals -2, our slope would be -4. And if we look at -2, our tangent line, we can see, would be a very steep negative slope. So that's what we're talking about when we talk about our derivative, and when we get those values, try not to get lost in the numbers, but keep in mind what you're actually solving for is the slope of the tangent line to your function at any given point. Let's take a look at this one, and let's practice applying power rule one more time. So the derivative of this function, 3 times 1 is 3 for our coefficient, and then we subtract 1 from our exponent on the variable, so that would be 3x squared. So if we look, let's say I plug in a -1 here. Whoops, there we go. So that would be 3 times -1 squared. And -1 squared gives us +1 times 3 gives us 3. So at -1, we can see that if we take the derivative of that line at that point, that tangent line is going to have a positive slope. And the value of that slope of that tangent line would be equal to 3. Now, if we were to plug in +1 and solve for our derivative, 3 times +1 squared would still give us a +3. And we can see that if we took this tangent line, that we would end up with a line that has that same slope of +3. So that's what derivatives are telling us. Derivatives are telling us the slope of the tangent line to our function at a particular value of x. For more, please feel free to visit our website at sandersontestprep.com or watch some of our other YouTube channels here on our other YouTube videos, here on our YouTube channel. Thanks for watching.